I want to welcome you all to Tree Week 2021. Hopefully you all have been able to get out and participate in some of the other great events that are going on during Tree Week, either in Lexington or around Lexington, or even Berea, Paducah, or Hazard area. I know they're also, and some other places are also hosting Tree Week as well this year. So we're super happy to have you joining us today for one of our UK forestry, natural resources and extension Zoom sessions. And today we'll be focusing on the basics of tree identification here in Kentucky. And my name is Laurie Thomas, and I'm an extension forester, which is I do forestry education outreach at the UK Department of Forestry and Natural Resources and Extension. So I'm glad to have everyone joining us today. And I'm going to be sharing screen here in just a second. And I don't think I can see your all's questions. So if we have questions or comments, go ahead and put those in the chat. And once I finish up with my going over some basics of tree ID, then we can get to, if there's any questions or comments or anything like that, I can go over those afterwards, since I don't have another host helping with the session today. So do pop those in there. And if everyone can, I think everyone is, but just stay muted. That will be helpful. And I'm super excited to have you all here today. This is one of my favorite subjects that I like to cover. I am a forester by education, but I really like just the thought of trees anyway. And I think it's perfect to have identifying Kentucky's trees as one of our early sessions for Tree Week. I know yesterday, if any of you got to join Dr. Ellen Crocker, that you all learned how not to kill a tree. So you learned some of the basics of tree care. And now we're going to kind of step back, and we're going to start thinking about and looking at the trees that we have around us and how we can learn to identify them and what tools are out there to help us identify those trees. So with that, like I said, if you've got questions, pop them in the chat and we'll get to them when I get done with the session. But with that, I'm going to share my screen, and we are going to start in with identifying Kentucky's trees. And I will let you know this is being recorded. So if for some reason there's something in here that you're like, I wish I would have remembered what she said, it is going to be recorded, and we will be posting those on our Department of Forestry and Natural Resources Extension website after Tree Week is over. But also to mention, I've got some other identifying Kentucky tree webinars that are also posted on that website as well, and identifying maples and identifying trees in winter as well. So there's a variety of others that already exist out there if you'd like to go back and watch any of those. So with that, we'll go ahead and get started. Like I said, again, I'm Laurie Thomas with the University of Kentucky Forestry and Natural Resources Extension, and I'm here today as part of Tree Week's Identifying Kentucky's Trees, one of our Department of Forestry's Natural Resources webinars. So let's get started with identifying Kentucky's trees. It's so much fun. But before we get into the nitty gritty, I kind of wanted to just talk about trees in our forest just a little bit in general, kind of introduce it, and then we'll zero in on our trees. I wanted to, and you all can just type this in, don't worry about it, I can't see your answers, but get us thinking about our trees in our forest in Kentucky. If anybody throws out, I've got a question up there, what percent of Kentucky is forested? So you all think about that. How much is it? 20%, 40, 50, 70, 80. So just kind of think, and if you all pop a question, pop a number in there, that's great. And I was going to say, if somebody said right around 50% of the state, you are right on. It's like 49%. So, but about 50% of our state is covered in forest land, which is trees. And that equates to about 12.4 million acres. And if you look at our state here, this is a nice map of the state. You can see we've got all the dark green is our forested area. We've got a lot of really continuous forest in eastern Kentucky. And then we've got this line that I'm running the mouse down right now. That's the Daniel Boone National Forest. So we got a big long line from north to south of Daniel Boone National Forest. And then we have scattered forests throughout the state, as you can see with the darker green in places. We've got the Knobs area here, and we've got stuff out around Land Between the Lakes out here as well. So we have forest lands scattered throughout the state, and it makes up about 50% of our state. So that's very good for us. So that's a great fact to know. So now let's see, how many different kinds of trees do you think we have in Kentucky? And this becomes one of those things when you start learning to identify them. And if somebody guessed more than 120 different tree species, you are right on. And that number kind of varies. Sometimes some trees are considered shrubs sometimes, and some just depending on size, but we have about 120 different native tree species to Kentucky. And the reason we have so many different species is when we go back here and look at our state, we're a long, narrow state, but east to west that way. So we've got here in the eastern part of the state, we've got the mountains. So that's a very specific type of habitat or ecoregion where a lot of trees can grow, but certain trees, you've got different types of topography, trees that grow down by the creeks and trees that grow all the way at the top of a ridge top. So you get a lot of different habitat or ecoregion types there. And then we go all the way across the state, all the way over to the Mississippi River, where we get bottomlands and out there, and a lot of our wetland areas, and very different kinds of trees grow there. And so for the way our state is east to west, we have a great variety of topography, and that east to west contributes to having so many different tree species. In addition to the fact that where we're located within the country, we're kind of in the middle, north to south, not in the middle of the country, but north to south in the eastern part of the country. And so we've got trees that grow up in the north in Indiana, Illinois, and Ohio that are found here. And then we have trees that are found in the south in Tennessee and Virginia that are also found here as well. We're just a nice, like, convergent mixing spot for so many different trees. And it has everything to do with our location within the country and within all of our wide variety of topography across the state. So we have about 120 different tree species. So as you can imagine, that can make tree identification a little tricky, but hopefully I'm going to teach you all how to use a tool that's going to make that a little easier. So I always like to go over why trees are important. And I'm sure you all are throwing out a bunch of different things, or things are popping into your head right now. And some of the biggies, trees are important because obviously they take in carbon dioxide and they release oxygen in that process of photosynthesis. So they help clean our air and provide us oxygen. They also are very important in protecting our water. And while a small photo here, you can see this creek, a nice, lovely shaded creek, is completely surrounded on those all along the edge with trees, which is important. It helps retain that soil from keeping the soil out of the water, to help stop soil erosion. And in addition, it provides shade for that creek, keeps that water cooler, makes it better habitat for the animals that live in and around that creek. So they're really good at preventing soil erosion, keeping our water clean. And their habitat for wildlife. They provide food, shelter for our wildlife, as we can see with our little screech owl here, which is a cavity nester. So it builds its nest within a tree cavity. So they're important for habitat for wildlife. They're also important for recreation. And I know most of us like to get out and recreate in the forest, whether it's a natural areas in our town, or we're going to go to one of the many state parks we have, or someplace in the Daniel Boone or at Land Between the Lakes. Really important for recreation. And that's also a big boost to our economy in this state as well. And then the products, and that may have been, sometimes depending on the groups you're with, that's the first thing they come up with, are products. Other times it's usually with school kids, it's usually clean air. But our forests and our trees do provide well over 2,000 different products, from the ones that we normally think of, our wood products. But then they also contribute to lots of different products that we may not think about. They're used in plastics, they're used in foods, and that some of that comes from wood residue, some of that comes from the chemicals that are in the tree itself. So trees are really important in contributing to the clean air, clean water, habitat for wildlife, recreation for us, which is again important for us physically and mentally to be out in nature, and then all the products that are in our everyday life. And one I don't have on here, but trees are also in this state, and as it is in many states, trees are very important because they contribute to the forestry sector of our economy, which is a really important sector in our economy. Contributes well over billions of dollars every year to Kentucky's economy, that forestry sector. And that means from managing forests to actually harvesting trees and making products from that as well. So also important to our economy. So with all of this importance, it's important to try to get to know some of our trees that we have out there. And in the process of identifying trees, there is a logical sequence to identifying your tree of interest. And that logical sequence we're going to find in a dichotomous key, which is simply a tool. Some of you all may have used them before. They have dichotomous keys for all kinds of organisms. We're going to use one today is going to be for a tree leaf key. So we're going to use this great little handy tool to help us learn to identify some of those many different trees we have out in the state. So this is the one we're going to be using today. It's the Tree Finder, the Manual for Identification of Trees by Their Leaves. This has been around since the 60s. It's a great little guide. It's a pocket guide, so it's easy to carry out in the woods. I know when I took dendrology in college, we had a great big, it was about a 400-page manual that we took out. Not a lot of fun carrying that thing around in the woods. And this little guy is about 80 pages. And it fits in your back pocket of your jeans or in a front shirt pocket. And it's real handy. It's very basic, but it covers a lot of trees. There's about 75 different trees in here. And it's good for the eastern half of the United States. And it's only $5. You can get these from Amazon. They also have the Winter Tree Finder as well, which is for identifying trees by their buds and twigs. But I suggest starting with the Tree Finder, by leaves. Identifying by leaves is usually a little bit easier to start there than with the buds. So this is the key that we will be using today. And when we're using a key, any type of key, but for us, for our leaf key, we're going to look at some characteristics of our tree and our leaves. And so we're going to start with leaves because that's the easiest place to start. But the characteristics, you've got the leaves, twigs, and buds. When we don't have leaves for in the winter, for our deciduous trees that will lose their leaves, you can identify trees with those. Sometimes flowers are helpful, but again, seasonal. Same with the fruit, can be helpful, but seasonal. And then bark. And I know a lot of people love to talk about bark, and bark is really cool. And we do have a few trees like this one right here that is very unique, and its bark is easy to identify it by. But a lot of our trees, the bark is not super characteristic. It's not super distinguishing, and it tends to change as that tree grows. So while it may be smooth and tight and maybe a light gray when that tree is small, as that tree grows larger, that bark may split and get deep furrows and darken up in color. So bark can be a tricky one, but for this guy right here, our American sycamore, it's a great characteristic to help identify this tree. We call it kind of a camouflage bark. It's that brown down below, and it looks like it sheds off or peels off to white above. So this is the kind of tree you could identify at a distance if you saw it across a creek bank or out in the woods somewhere. But today we're going to focus on leaves because that's an easy one, and we still have leaves out there to do this with. But a quick warning though, leaves of the same species, and even on the same tree, may not look the same. So you want to make sure that you look at numerous leaves when you're doing identification. So when you come up to a tree, don't just focus on just one leaf. Make sure you look at several, because let me give you an example right here. So we've got black oak. Now this isn't from the same tree, but it is the same species. And you can see with this oak leaf on the left right here, it's a very broad leaf. While it has bristle tips on it, it doesn't look like the leaf in the middle. This one's got much deeper indentations, or sinuses is what we call those indentations. And then this one looks like it's evergreen. It's shiny and almost looks leathery. But these are all from a black oak. So you want to make sure you look at numerous leaves, and depending on where it's growing in the tree, like this guy over here on the left is probably more of a shade leaf growing lower down in the canopy. So it's a little bit broader, a little bit thinner, trying to take in that sunlight. And then this one over here on the right, this is probably being fully exposed to solar radiation. So it's gotten thicker to help as a form of protection. So just make sure you look at more than one leaf. And the same goes for when we're looking at our needle-bearing trees or our conifers. You want to make sure you look at more than one needle or more than one set of needles, because sometimes one falls off. Okay, so when we're using our tree key, there are certain characteristics that are always going to appear, and this is the order that they're going to be in the tree key. So there'll be questions or statements, and it's usually the first one. Always the first one is, does the tree have needles or does it have broad leaves? And what that means is that a needle-like tree, like this bald cypress, you've got those short, in this case, short, soft needles, or it could be like a pine tree and have stiffer, sharper needles. Or is it a broad leaf, like our hickories and our oaks? And that, just think of it like your hand, a nice broad flat leaf. Another difference between these two, most of our conifers are evergreen, so they will keep their needles throughout the year. They do drop needles, but it usually takes longer. They'll retain them for a couple of years, and they don't drop them all at once. It's just one here and one there, so they appear to be evergreen. They retain their leaves year round. Whereas our broadleaf trees are going to lose their leaves every fall and grow new leaves in the spring. And these are also called deciduous trees, so they're going to drop those leaves. Now in Kentucky, we only have 8 different needle or conifer type trees, needle bearing trees. All the rest of those 120 species are broadleafs. So we're going to focus a lot on the broadleaf. But we'll just go real quick over our conifers, or our cone-bearing needle type trees. So these needles are going to come in a couple of different forms. We've got our scale-like needles overlapping. We're going to have single needles. So they'll just be born individually on that twig, or they're going to be in groups. So let's look at each group that we have. So we've got eastern red cedar and northern white cedar. Both of those are found here. And you can see they have overlapping scale-like needles. And on both of those, this is the eastern red cedar on top. And it'll tend, in its new growth, will be a little bit prickly that first year. And then it's compressed, as you can see here. And this is last year's growth. With our a northern white cedar, it doesn't have those sharp spines, that sharp new growth prickles, but they do have those overlapping scale-like needles. And then we've got our conifers that have single needles that are, so you can see with our eastern hemlock, there's just one single needle. They're not in groups, just a single needle is born on that twig. The same with our bald cypress, just that single needle. Now, a quick note, bald cypress is not evergreen. That is one of our conifers that isn't. It will lose its leaves in the fall, and it grows all new needles in the spring. And then we've got eastern white pine. So this is the one, a lot of us have this planted in neighborhoods. It makes a great screen tree. But eastern white pine has 5 needles. Its needles are grouped, and you can see this like a little wooden cup down here. If you look where I'm moving the cursor, a little wooden cup that holds together 5 needles. And those needles will be nice and soft, but that's, you make sure you check several of those little bundles to make sure you've got 5. And always remember white pine as having 5 needles, for white, WHITE, 5. That's 5 letters, and it's got 5 needles. So that's white pine. And then we've got pitch pine. Now this is definitely more of a forested tree. Don't usually plant this tree that much, but pitch pine always has needles in groups of 3. So if you can remember that, groups of 3 with pitch pine. Our other more forested species of pine is our shortleaf pine. And shortleaf looks a lot like pitch pine if you walk up to them in the woods, with the exception that shortleaf will have needles in pairs of 2s and 3s. So that's why you want to make sure you look at multiple groups of needles. And then lastly is the Virginia pine. And Virginia pine has needles in groups of 2, and you can see it real nice right here where I'm running the cursor. And their needles are actually kind of like twisted around each other a little bit. So Virginia pine, also not one we plant a whole lot. We have used it in both eastern white pine, and Virginia pine is used somewhat in the Christmas tree industry. It's shaped up, obviously, but not planted a whole lot. This would be more of our forested species as well. So those are our conifers. Like I said, there's only 8 of them, so we won't spend a lot of time. You'll be able to figure those out in your tree key, because your leaf finder, if you get one of these manuals, has all of these different conifers in it. So now let's look at some of our broadleaf key characteristics. We got a lot more species that have broad leaves, and we're going to look at leaf arrangement. So we've already tackled talking if we have needles or leaves. Now, the next thing you're going to look at in your tree key is leaf arrangement. And we'll talk more about this leaf form, leaf margin, what the edges of those leaf looks like, and leaf tips sometimes, and also what that leaf base looks like can be sometimes a distinguishing characteristic. And when you're looking at, and I just popped this in here because the buds are helpful when we're looking at leaf arrangement and leaf form, and you'll see that on the next slide or two. But the bud is simply the location of the new stems, fruits, and leaves. And when we look at this bud right here, we have our terminal bud, the one at the very top, and that bud's responsible for shoot elongation. And then we have our lateral bud down here, and this is going to be next year's leaf. And we have our leaf scar right down here. So that's where last year's leaf was. That leaf has fallen off, and you can see that leaf scar. And then it's actually labeled down here as leaf scar. So being able to see those buds, it's going to be helpful, especially to helping us determine our leaf form. They're very useful. So we'll look at just a few buds. I love this one. This is pawpaw. It looks like I always think of it like a moth's antenna, one of those bushy antennas. And here's our maple bud. They're nice and little, tucked in the stem, the leaf stem right there. Oh, and this is the state tree. This is our yellow poplar terminal bud. It looks like a duck's bill. And this is a buckeye bud, and they're quite large because a buckeye has a pretty big leaf. And you can see it's got all these nice little bud scales on it. And this one's always cool. This is our American beech, and it has those sharp pointed buds. I know as kids, we always call those cigar buds. They look like little bitty cigars. And then we've got our oak buds, and oaks have kind of that unique bud, that terminal bud where there's lots of buds at the tip there. So just a few to take a look, see at, and we're going to look at some more when we use our tree key in just a minute. But the next thing, now that we've looked at, we know we have needles or leaves, we know it's a broadleaf. The next question that you're going to run into, or statement in your tree key, is going to ask you about the leaf arrangement, how those leaves are arranged on that tree. And you see we've got three different types of arrangement. We have our oppositely arranged leaves right here. And our opposite leaves, this is nice. We only have 4 groups of trees in Kentucky that have oppositely arranged leaves. Now that's more than 4 species, because we've got multiple maple trees, multiple ash trees, several dogwoods, and 2 buckeyes that we find here. But these leaves are, as you can see right here on the diagram, they're right across from each other on that twig. They're oppositely arranged. So if you come up to your tree and you see, I got oppositely arranged leaves, again, make sure you're looking at several sets of leaves, because sometimes they can grow really close together. But if you can remember the mnemonic MAD buck, standing for maple, ash, dogwood, and buckeye, you can remember, hey, maybe I've got a maple, an ash, a dogwood, or a buckeye. So those are oppositely arranged trees. Now, all the rest of them are going to be alternately arranged. So that's a lot more of our trees have alternately arranged leaves. And these are leaves that are staggered along that twig. As you can see, they're not right across from one another. And then we do have one that is whorled, and those leaves grow around that twig. And the one we find here is our northern catalpa, and it's not found all over the state. But here in the bluegrass area, it's the tree that has those long, thin seed pods that are out right now. They're very long and they're straight, not the curved ones, but the long, thin, straight seed pods. That's from the northern catalpa. All right, so let's just take a look at a picture. So you can see our alternately arranged leaves and buds. You can see that here's the bud, and there is a leaf growing there with that bud, and this is on our American beech. These are alternately arranged. They're staggered on that twig. And then we've got our oppositely arranged buds over here. And in fact, this is a maple. Remember, maples, ash, dogwood, buckeye, oppositely arranged. But you can see these leaves grow right across from each other on that twig. Okay, so now the next question, you've answered that in your tree key, is going to be, it's going to ask you something about leaf form. And that may be a new term, a new thought for some people, but leaf form is, we have 2 kinds. We've got simple, as you can see in this diagram, and then we've got this other called compound. And within compound, we've got different types of compound. But to determine if you have a simple or compound leaf, you're going to look at your leaf and you're going to go down its stem or its leaf stem or petiole, as you can call it, and see if there is a bud at the base. And if there is a bud at the base of it and you look back up and you only have one single blade, that is a simple leaf. Now let's come over to this one that says compound. So I'll look at what I think is a blade right here. We'll use this one down here. And if I look at the base of it, I'm not finding a bud there. I don't find a bud at the base of this blade. Instead, I go all the way down this stem and I find that my bud is all the way down here. And so I actually have a compound leaf. This whole thing right here is one leaf and it's made up of 5 leaflets. And this would be called palmately compound because it's palmate like your palm. But that's how you can tell the difference. You look for that bud. That's why I was saying those buds are important, especially in leaf form. And this time of year is great because buds have been set for next year. Early in the spring when you're doing this, it can be a little trickier because the trees haven't set bud yet for the fall. But then let's take a look at this guy over here. So if we look at the base of what we think are the blades, the leaf, we don't find any buds along this stem. So then we go all the way down this longer leaf stem. We find that the bud's down here. And this whole thing is a pinnately compound leaf. It's called pinnately because those leaves grow across from one another on that leaf stem. And this whole thing becomes one leaf that's made up of 2, 4, 6, 8, 10, 11 leaflets. Trees like our black walnut is an example of a pinnately compound leaf. Our hickories are pinnately compound. And then we've got this fella over here, this great big leaf. If we looked at the base of these little blades, we don't find any buds there. We keep going down and we're not finding a bud at the base of what we thought maybe that was a leaf. We keep going down this stem until we find that our bud is all the way down here. And this is a doubly or bipinnately compound leaf. One bud down here for this whole leaf, and it's made up of multiple leaflets. So those are the different leaf forms. Like I said, we have numerous trees that are compound, but many of our trees have a simple leaf form. All right, so let's look at a few photos of this. So we can actually see our buds right there, and we see a leaf stem and we see one blade. So this is a simple leaf form. Okay, and then we've got this guy right here. So we're looking at the base of these and we don't see any buds, but we do see you can actually see these buds in the photo. We've got these rather pronounced buds. So this whole thing is a leaf. And this is actually an example. This is black walnut. It has a very large leaf made up of multiple leaflets. Okay, the next thing you're going to look at in your tree key is going to ask you about leaf margins. And we have entire or unlobed, and that means there's no indentations and there's no serrations around the edge of that leaf. It's nice and smooth. Or we can have lobed leaves, which means think like an earlobe. There's this, you've got an indentation, which is a sinus, and then this lobe that's sticking out on the outside. So you can have lobed leaves, and these are examples of oaks. We've got a red oak at the top and a white oak at the bottom. And then you can have serrated leaf margins, and that looks like they're serrated like a steak knife or a bread knife if they're farther apart. But you've got those little teeth all along the edge of the leaf. And sometimes those teeth all look alike, or sometimes they're of different sizes. And then you can have lobed and serrated leaves. And this is one of our maples. So we've got 3 lobes here. Those V-shaped indentations are the sinuses, and then the edge of that leaf is serrated. So those are some of the different types of margins that we're going to run into in our tree key. Okay, quick test time. Is this a conifer or broadleaf? Hopefully everybody gets conifer. Yes, we have needles on this tree, not broadleaves. Do we have opposite or alternately arranged leaves? Hopefully everybody's answering opposite. You can see those are directly opposite from one another on that stem, and you can even see the little buds in the petiole, the leaf base, the leaf stem there. Alternate or opposite? Hopefully we got alternate. We've got alternately arranged buds and leaves, and those stand out nicely. Ooh, this one's a little trickier, but our bud does show up quite well. Right there's our bud. So we have a compound leaf. This is a bitternut hickory, a nice big pinnately compound leaf. All right, how about our leaf margins? Are they lobed? Are they entire? So yes, if you guessed lobed, you got it. Yeah, we've got our indentations, our sinuses here, and then we have the lobes sticking out. And this is a white oak, so it has lobed leaves. All right, is this statement true or false? This leaf is lobed, serrated, and compound. Well, I don't see lobes. The edges look smooth, and there's our bud with one stem and one blade. So we have that this is a false statement. This leaf is simple, it is not lobed, and it has entire margins. Good job. Entire or serrated? Hopefully everybody says entire because it's nice smooth margins. Which of the following does not fit the sequence? Is it A, B, C, or D? Hopefully everybody guessed C, right? It doesn't have serrated leaf margins. We've got really broad serrations on A, we've got fine serrations on B, and broad serrations again on D, but we have an entire smooth leaf margin. Awesome. Okay, so we've gone through some of the basic characteristics, and this is how our tree key is going to work. But I've actually taken photos, and we're going to go through the little booklet together with two different samples. But this is a super abbreviated example of what we're going to do. It says, does the tree, the first question you're going to come to is, does that tree have needles or does that tree have leaves? Well, this is our sample, and hopefully everyone's saying that it has leaves or broad leaves in this case. So it tells us now we go down to B. So, you know, a dichotomous key, there's going to be two options, di meaning two. We go down to the two options at B. It asks, are these leaves opposite or the leaves alternate? Well, I've got them circled for us here. And hopefully everybody is saying that these are staggered or alternately arranged on that stem. So we have alternately arranged leaves. And so we go down to C. And when we're down at C, it asks if the leaves are simple or if the leaves are compound. So we've got one leaf blade here, and we've got our stem right there. You can't really see the bud, but I've circled those for you. So we know we have a simple leaf. So now it tells us to go down to F, and bingo, it tells us what our answer is now that we have a serviceberry. So like I said, super abbreviated. The booklet we're going through has 70 pages, so you've got lots more options. Okay, so let's ID this tree. Okay, so in our little booklet, it starts at page 5, or it could be 1 depending on your tree key. But this one says to start here. And so the first question, remember, it asks you, does the tree have needles or does it have leaves? And when we look at this guy right here, hopefully everybody's saying it has leaves. So now we're going to remember that little symbol, which looks like a stylized or lollipop tree, and carry that symbol over with us to page 14. So we flip over to page 14. We go to the very top bracket, and we've got that lollipop or stylized tree. And now this next question is just like I said, it asks you, the first one is it needles or broadleaves? The second one is going to be about leaf arrangement. So it asks you if the leaves or buds grow opposite like this, and it even shows you what it means, or if the leaves or buds grow alternately like this. And I've circled these for you, and you can see that hopefully everybody got that they are alternate arrangement. So now we remember what that twig looks like with the alternately arranged branches on it, and carry that over to page 21. So that's the second bracket over there on page 21. You can see they're alternately arranged. Now it's asking us about leaf form. It says if the leaves are compound, composed of several leaflets, and look, it even tells you, gives you a hint if you don't remember what that means. It says you can tell leaves from leaflets because there is no bud at the base of a leaflet, or if the leaves are simple, not composed of leaflets. Well, if we look closely right here, we see that there is a small bud right there, and we have a stem and one blade. So we have, remember, we have a simple leaf. So with this simple leaf diagram, we carry that over to page 28. So flip over to page 28, and that's the bottom bracket that we'll find there. Now it's asking us a little bit about what the margins look like. Remember, that was the next set of questions. So it asks us if our leaf, and it's kind of oddly worded, if the leaf has neither teeth nor lobes, go to the next page. Or if the leaf has teeth of any kind or wavy margins or lobes. Well, when we look at this, this was an example of our leaf that had entire margins. It did not have any lobes, in fact. So we know there aren't any indentations in this and there are no lobes. So we want to follow this individual leaf over to the next page without lobes, and it's the top bracket this time. Now this is asking us about the tip of the leaf, and we didn't discuss this, but there's not a whole lot of times does this pop up, but it's easy enough to figure out. It says if the leaf is tipped with a single bristle like the tip of the needle, and it'll be a hair like it, you can tell there will be a part that sticks out, and you can even see it in this diagram. Or if the leaf has no bristle at its tip, but the leaf can be pointed, and our leaf is pointed and it doesn't have a bristle tip. So we want to follow this diagram over to the next page, that little symbol over to the next page, and it's the very top bracket because there's no bristle tip. Now it asks us some more about the shape of the leaf. If the leaf is heart-shaped with veins branching from the base, or if the leaf is not heart-shaped. Well, if we look at our leaf here, it looks like the veins are all branching from the base of this leaf, and I'm running my cursor down those leaf veins, and it is indeed heart-shaped. Not super heart-shaped, but it is heart-shaped. So what we've got is a redbud, that's Cercis canadensis. And many of you all may have known that when we started it, but just to practice going through the key to see how it works. So we've got our eastern redbud. It's a great little understory tree. A lot of us will have this planted in our yard. It's easily found in the forest. It likes to occupy disturbed sites as well. You'll see it a lot of times growing along road cuts and whatnot. Beautiful spring flowers, lovely heart-shaped leaves. And then it is in the pea family or the legume family. So it looks like pea pods or bean pods hanging from it this time of year. And in fact, the one outside my window, they've already turned brown. The fruit has on that. So that's our eastern redbud. See, this is I wouldn't say it's easy, but this is manageable, using a tool to help you identify trees. So let's try one more. Let's ID this tree. We may know what it is, but let's go through our key and see what we've got. This is good practice. It asks if the tree has leaves or does it have needles? Well, if it has, we know this is a nice broad leaf. We're going to take that symbol again over to page 14, and it's the top bracket. Now it's asking us again about leaf arrangement. Do those leaves or buds grow opposite, or do the leaves or buds grow alternately? Well, I've already circled it for you here, but you can see those leaves are right across from each other on that twig, and you can actually see the little buds, that this is oppositely arranged. So remember what we said about oppositely arranged. It could be a maple, an ash, a dogwood, or a buckeye, okay? So now we just take in this symbol, and it's the bracket right below. We've got our oppositely arranged leaves. So now it's asking us about our leaf form again. If the leaf is compound, composed of several leaflets, or if the leaf is simple, not composed of several leaflets. So let's get a little more close up here. So we've got our bud, and we go up that leaf stem and we see one blade. So that means it is not made up of several leaflets. It's only made up of one blade. So we have a simple leaf. So now we're going to follow this symbol for a simple leaf over to page 18. And that's the very top bracket. And on page 18, now it's asking us about some of the venation in our leaf. It says each leaf has a single main vein with smaller side veins, and it even gives you a diagram what it means. And that would be more like a pinnately venation. So those would be one main vein, and they're right across from each other off that main vein, and is without teeth or lobes. Well, I don't think that's matching our leaf. And then the next option is if the leaf has 3 to 7 main veins radiating from one point and it's lobed. Well, let's see, we've got 3 main veins right here, and they're radiating from that leaf stem. And in fact, we've got 3 lobes too. 1, 2, 3, actually 5. 1, 2, 3, 4, 5 lobes. So we have a maple. And so this is easy. We don't have to go far. We're just going to pop down below to this next bracket. And now we're trying to figure out what kind of maple we have, because we have numerous maples here in the state. If you can think about sugar red, silver maple, we've got box elder, which is an unusual one. We've got black maple, striped maple in one county. So, and Norway maple, we've got lots of different maples that we can find around the state. So now we're trying to figure out which kind it is. So now it asks if the notches between the lobes are V-shaped. So, and it even shows us what it means by V-shaped, a nice sharp pointed V, or if the notches are U-shaped. And I always like to stick my finger in there for like the U shape. And that looks more like the outline of my thumb as opposed to a nice sharp crisp V. So we actually have this one right here that we have more of that U-shaped notch or sinus. So remember what that symbol looks like with the arrow pointing into this, to that notch, and take that over to page 20. And that's the bottom bracket. Well, it looks like we might have an answer here. So at that bottom bracket, we've got two options. It asks us if the leaf stem shows a milky juice when broken. This is where it's good to be in person, but the leaf is usually wider than long, and the base of the leaf is not curving. The base of our leaf looks like it's curving. And I'll tell you this, if I broke this off, there would be no milky juice. And the leaf, and this is our second option, if there is no milky juice and the leaf is about as long as it is wide and the base of the leaf is curving. Base of the leaf is curving, and our leaf is about as long as it is wide. And you can figure that out if you're like, I don't have a ruler. The back of those tree finders, they have a ruler on them. So that helps you. Sometimes they ask questions like this, is it as broad as it is long and whatnot. So we have a sugar maple, which is just starting to change out there right now. And we're starting to see the fall colors with our sugar maple. And sugar maple, an awesome tree. It is a beautiful landscape tree. It's obviously what we get maple syrup from. And one of the trees we get maple syrup from. It's the best sugar producer. And it's also a very important wood. The basketball floor at Rupp Arena is made from, they call it hard maple, but that means sugar maple. So sugar maple, and we were able to identify, going through that booklet pretty quickly. And it takes practice to do this, but you can do it as well. And if you ever get the opportunity to go out with somebody and you have one of these booklets, work on it together. It makes it fun to try to do this together. And I've got a few other tree ID resources. I did want to mention, this is a great activity if any of you work with youth, to have, get a couple of these little guides starting from about 4th grade on. This is definitely a very usable guide, as you all saw it, easy to read. If you're not sure about what something means, it's usually explained for you in there. But learning some classification and looking at characteristics is a good thing to do with youth. And this could be a great activity to use one of these tree guides and do a little basic tree identification. But there are some other resources out there. Many of y'all may have iNaturalist. It's a free app that you can download onto your phone. It's not a key. It actually is based on, you take a picture and there's this huge database, and it's running through this database, and it's going to give you options of maybe 10 to say, this is what my organism or my leaf is. So that's a free app that you can download onto your phone. You can also use it on the website as well. Another one is Virginia Tech Tree ID, and they also have an app that you can download on your phone. It's pretty, it's very robust, and it can be a little tricky to use just because it has 400 or 500 different species in there. But it is a really good resource. Now, their website is also awesome. You can, if you bring your sample in, you can sit down and go through the website, and it's all picture driven, photo driven to help you. It'll get you at least to the maples, and then and it shows you pictures of, 15 different maples, which one matches yours. Plus, they have a lot of great fact sheets on trees there too. So if you're interested in some of these trees and might want to plant one, they've got some really good fact sheets at Virginia Tech Tree ID. And then there's the Arbor Day tree identification. They have a little key. They actually have one you can buy, but it is a little more expensive. It's runs about $19, but it is a dichotomous key as well. And they have some stuff online and some great info on trees as well. And then there's also at our UK Forestry and Natural Resources website, we have a whole slew of tree ID videos. I'm walking you through, Doug McLaren walks you through pretty much what we've just done here in this Zoom session, but it's short videos on that. And in addition, we've also got other webinars listed there with other tree identification and winter tree identification and maple identification on there as well. And then we also at our UK Forestry and Natural Resources Extension YouTube channel, we have the Tree of the Week. Excuse me, let me get a drink here. Most weeks I try to do a different tree each week, highlighting one. There's a short video, 5 or 6 minutes, about a different tree, goes over some of the identification characteristics, some of the natural history, and some fun facts about those as well. And I think we've got about maybe 65 trees up there so far, so check those out. And then our UK Department of Horticulture also has a great set of about 80 different fact sheets on native trees of Kentucky. And they approach that from a horticulture standpoint, like you're thinking of using them as ornamental trees as well. So some really good resources there. And then I wanted to just promote a few of the other events that out of UK Forestry and Natural Resources we are doing for Tree Week, but there's tons of other activities for Tree Week, and hopefully you've gotten to do some of those. Like I said yesterday, was with Dr. Ellen Crocker on how not to kill a tree. And then tomorrow we're going to have urban and community forestry plus tree planting techniques on our From the Woods Today video program that we do every week at 11 a.m. and you can check that out. And then on the 13th, we have Mission Possible, Seek and Destroy Invasive Plants with Dr. Ellen Crocker over at Wellington Park here in Lexington. You're actually going to get out in person and look at, learn ways of treating and trying to tackle some of our invasive plant species. And then on the 14th, we'll have Kentucky Maple Syrup Project. This is, we have maple producers all around the state, and Billy Thomas and Dr. Jacob Muller are going to talk more about this project and how maybe you can even get involved with that as well. And then we'll wrap up Tree Week with wildlife and trees with Dr. Matt Springer, and talking about trees and how they benefit wildlife and what trees you could plant in your yard that might help attract wildlife as well. So hopefully you can join for a couple of those other sessions. With that, I'm going to stop share and let's see. Hopefully everybody enjoyed it. It wasn't too much. We don't get a real long time to do this. Let me go back and see if we've got, it looks like we do have a couple of questions. Okay, I'm going back up. Okay, good. It just answers great. I see I actually have, I recognize some names on here. Hello to those in Master Naturalists. Hello, Colton, who is one of our 4-Hers who's been very involved in our 4-H Natural Resources and Environmental Science Academy. Thank you, thank you. So let's see, I do have a question. Any special tips? So Pony asked if any special tips for differentiating, oh, that's a hard one, Pony, between a Shumard oak and a northern red oak. I'm working on creating a tree trail map yeah, the branches. And I was gonna say, Pony, maybe we'll talk separately because there are a few good characteristics, but sometimes they're not always there. But I was going to say, if you've got a minute, you can stay on when everyone gets off and we can chat, and I can turn off the record.
Sounds good.
Okay, great. So that's okay. Pony started. Okay, let's see if there's any other questions. Awesome, great. Good. How to preserve leaves for art. Oh, a craftsperson. I wish in my office, I've done this as a project. This is a great time of the year to do that. And I'll just take a second to talk about this, but we did this as a project when I was at McConnell Springs, had the kids collect different leaves and then create animals out of it. So I did a cat, and somebody did a turtle. So you found leaves that you could glue down. We glued them onto construction paper and pieced them all together. And it was leaf art, and it made an animal, or, you know, you could just do leaf art, but then we took Mod Podge and put over that so that leaf would seal it in to that page. And that way the leaf, if it dried out, it didn't matter. And it was a lot of fun. We had cats, someone did an alligator. Like I said, there was a turtle. So yeah, with all the different shaped leaves out there, there's a lot of stuff you can do. And this time of the year, it's really nice to do it because you got all that different leaf coloration that we're starting to see out there now that the leaves are no longer producing chlorophyll. We're seeing all the rest of those colors in those leaves. But other preservation techniques, obviously you can press leaves, in which we do in 4-H, our 4-H leaf collection project. And you don't have to buy a plant press. You can put it between, just do some kind of paper between something heavy and neatly lay your leaf out and press it that way. Is another thing. And then there's also photosensitive paper. If some of you all may have seen that, and you can put a leaf on that and then set it out in the sun, and it will give you a wonderful, cool leaf outline of your leaf. And then there's always leaf rubbings. You know, make sure you lay your paper over the rough side of the underside of that leaf and take a crown and rub it on there, and you can make a really cool leaf rubbing as well. Or even leaf prints, paint that backside or that underside of the leaf where you can see those veins, and then lay it down on a piece of paper, make some cool artwork that way. Awesome. Well, I hope everyone enjoyed identifying Kentucky's trees, just the basics, and hopefully in the future we'll be able to maybe get together and schedule one. I know the first year we did Tree Week, we did this in person, and hopefully next year we'll be able to actually do it in person on campus and go around and identify some of the really cool trees we have on campus. But with that, I will stop record and say goodbye to everyone, and happy Tree Week. And hopefully we'll see you at one of our other sessions, or join us tomorrow from the woods today on our video show. Thanks. Bye, everyone.